We have talked about the non-preemptive one. In the last video, we'll talk about preemptive one, the real deal here. It is also called as Srtf, shortest remaining time first. I'll repeat, shortest remaining time first. In the exam it will come and you have to assume that it is preemptive version. Now if you see, I have left some space here and in a second it will be clear. And by preemptive, I already told you that the process can be stopped. Just keep in mind the smallest process will be given preferences. Now let's make the Gantt chart and do the analysis, right? This time we'll do the clearer Gantt chart like this, like this. It will start at 0. Any process arriving at 0? No, the process arrival. Let's make it a little up, right? Let's make it here. Process arriving at 0? No process arriving at 1. Yes, for one process arriving at 1. So can I execute it for the 7 units of time? No, I'll execute it for 1 unit of time, and you'll know why. P1 1 unit of time, so the burst time reduced to 6. Now at 2 unit of time, another process P2 is coming and it has smaller burst times. 5 is smaller than 6, so we'll schedule P2 here, execute it for 1 unit of time. At 3 unit of time, any smaller process coming? Yes. P3 is 3 and reduce it. Is 3 smaller than 4? Yes, it is smaller than schedule P3, execute it for 1 unit of time, reduces. At 4 unit time, any smaller process coming? Yes, P4 is coming, 1 is smaller than 2, so schedule P4, it will be completed. P4 is done. Now at 5 unit time, it's 2. If the burst time is same, see the arrival time 3 smaller, schedule P3, and now execute it for 1 unit time. Now reduce it. At 6 unit time, any new process coming? Yes, P6 is coming. Is 3 smaller than 1? No, so continue executing P3. P3 done. Yes, P3 done. Now if let's see, at 7 unit time all the processes have come, so we don't have to look for the any other process, so we can execute for the whole unit of time. You'll see what I mean. At now the smallest process here available is P5, right? So execute P5, not for 1 unit of time, for 2 unit of time, whatever the burst time, because no new smaller process will be coming in the meantime. That is why I'm executing it for the 2 unit of time till 9. Next smaller process it is P6. P6 executed for 3, 12. Next smaller process is your P6 is done, your P5 is done, your P2 is not done, so let's execute P2. It's smallest, right? 4 unit time, 16. Now at the last P1, it requires 6 unit time. At 22 to be completed, so write completion time 22. P2 completion time is 16. P6 completion time is 12. P5 completion time is 9. P3 completion time is 7. P4 completion time is 5. TAT is simply CT minus 80. CT minus 80, 22 minus 1 is 21, 16 minus 2, 14, 17 minus 3, 7 minus 3, 4, 5 minus 4, 1, 9 minus 5, 4, 12 minus 6, 6. If I add these up, I'll get it to be 10, 50. Waiting time is simply TAT minus burst time. So the values will be 14, 20, 21 minus 6 is 14, right? 21 minus 7, sorry, burst time was 7. This we have to see, right? 7, the initial burst time. 14 minus 5 is 9. 4 minus 3 is 1. 1 minus 1 is 0. 4 minus 2 is your 2. 6 minus 3 is your simply 3. If you add them up, it will be 29, I guess. Yeah, 29. So your average TAT is simply total TAT divided by number of process. Total TAT is 50, total process is 6. It will be 8.33. Your average waiting time, it's total waiting time divided by total process. It's simply 29 divided by total process is 6. 29 divided by 6, so 4.83. This is how you do it. So thank you, like and subscribe and share if you like it. So that's it. Okay, thank you.